Good evening to another online Zoom teaching. In case you have any comments, you forward that through the WhatsApp number 076-627-336. My name is Momokini. We looked at some basic aspects last in physics. We were able to look at the question 1 and question 2, preferably on the question paper. So if you are able to go through the videos and you are able to look at the samples, we are now solving some questions today to serve as examples to those things that we did. In as much as possible, you are able to go through these things. You can solve any questions anywhere you see them. So we are starting with the question. The first question you are seeing now was a question that came in 2004. The first question we are dealing with came in 2004. The question reads, in his first attempt, a long jumper took off from the springboard with a speed of 8 meters per second at 30 degrees to the horizontal. He makes a second attempt with the same speed at 45 degrees to the horizontal. Given that the expression for the horizontal range of a projectile is u square sine 2 theta divided by g. If you can recall, we were able to derive an equation like that here. The equation that we derived here says u square sine 2 theta divided by g, where all the symbols have their usual meanings. What does that mean? You should know the meaning of u, which is initial velocity. You should know the value, the meaning for the theta, which is angle. You should know that g is gravity. That is what it means. Show that he gains a distance of 0.8576 meters. That is what the question is requiring us to do. Now let us solve this one. We say solution. There were two attempts. There were two attempts here. The first attempt, we categorize them now by attempt. First attempt. We have first attempt here, and here we have second attempt. Second attempt. These were the attempts. Second attempt. Now we go to the first attempt. According to them, in his first attempt, a long jumper took off from a springboard with a speed of 8 meters per second. So you say u in the first attempt is 8 meters per second. 8 meters per second. U is 8 meters per second. That is the speed at that particular time. Now at 30 degrees, theta becomes 30 degrees. That is the angle. The moment you are at that point, you can get the range. If you are at the initial velocity is 8 meters per second, and you have the angle at 30 degrees, we now know that the formula for the range is given here, the range of the projectile. Last week, we said the range of the projectile is u square sine 2 theta divided by g. So the range becomes u here, the initial velocity is 8, that is 8 square sine 2 theta. The theta is 30 degrees, that means 2 times 30 divided by the gravity according to them is 10 meters per second square g. So the range becomes, if I use calculator now on that, I will say 8 square, that will give me 64. I have sine 2 theta. 2 times 30 becomes 60. I have to divide this one by 10. I will now use 64 sine 60 divided by 10 on the calculator. If I do that, I'm getting, when I say 64 sine 60, I divide everything by 10, I get a range of 5.5426. 5.5426 meters. That is what I will get in the first attempt. Let us now go to the second attempt. In the second attempt, we read the question. He makes a second attempt with the same speed, and the speed here is 8 meters per second. They are saying the same speed. So in the second attempt, the speed is also 8 meters per second. After that, the angle, he makes a second attempt with the speed of with the same speed at 45 degrees. So the angle now, theta, becomes 45 degrees. If you recall the last class, we said the moment the angle is 45 degrees, that is maximum range. The maximum range always occurs when the angle is 45 degrees. And the formula we stated, when the angle is 45 degrees for maximum range, the moment, anytime the angle of projection is 45, is maximum range. And the formula becomes only u square divided by g. No more sin 2 theta for range. So if that is the case, u is 8, that is 8 square divided by 10. 8 square is 64. When you divide that by 10, you get maximum range as 64 divided by 10 is 6.4 meters. That is what he got. The range he got in the second attempt. Now the question says, show that he gains a distance of 0.856 in the second attempt. You look at the two figures. You are saying first attempt, the range was 5.5426. When you go to the second attempt, the range was 6.4. So this figure here is greater than this. The last figure, the maximum, we call that maximum. The maximum figure is greater than the first attempt. So for you to get gain, it will be the highest value minus the smallest value. That is what we call gain. Gain means the highest value minus the smallest. So we have the right to now say gain in distance, gain in distance, gain in distance in second attempt. Gain in distance in second attempt will now be the final value we have here, which is 6.4 minus 5.5426. So if I do that, I say 6.4 minus 5.5426. We are going to get 0.8576. 0.8576 meters, which they said you should show. That becomes the answer to that. We look at the second question, still in 2004. That tells you that this thing is something you cannot escape. The first one we solved was 2004. This also was in 2004. Now they are saying a stone thrown horizontally. If you can look at the cases I looked at, when we say horizontally, it means something that is dropping. We say an object that is projected vertically downward is the same as horizontally projected. So if they have used the word horizontally, that means they are now saying a stone thrown horizontally is the same as vertically downward. From the top of a vertical wall, let us get a sketch of that one. Let us call this the wall, that is the wall, and this wall is on the ground. That is the ground surface. This happens to be the ground. The wall is on the ground. Now the top of the wall is here. And there is a stone at the top. Let us say there is a stone here. When you release the stone will come and hit the ground. The stone that is at this point, if you look at those videos, you can see the diagram. The stone will hit the ground. We say when the stone reaches the ground, it will cover a distance on the ground. And the distance it covers on the ground is known as the range, the horizontal range. The moment the stone falls on the ground, it will move on the ground. And that horizontal distance it covers on the ground is known as the horizontal range. Now, the height of this building, we don't know. That is one of the questions here. You find the height of the wall. We don't know the height. Now, this whole thing is projected with a velocity. There is a velocity at which this thing is moving. A stone thrown horizontally from the top of a vertical wall with a velocity of 15 meters per second. So the velocity here is 15 meters per second. Hit the horizontal ground at a point 15 meters. When this stone is hitting the ground here, this is the horizontal ground. It hits the ground at this point. And they are now saying that point is 45 meters from the base of the wall. The base of the wall is here. The stone has hit the ground at this point. And they are saying that distance from the wall is 45. So where the stone hit to come to the wall is 45 meters. So if you are smart enough, they are telling you that the horizontal distance covered is 45 meters. From the base of the wall, we are now asked to calculate the time of flight of the stone. And you know the time of flight is the time required by the object to be in air. If you can now recall that, we said that the formula for the range, one of the equations I wrote for the range was u times t. If you recall that the formula we stated here for the range was range equals u multiplied by t. Now if that is the case, the range at this point, we have the range which is capital R, and that range is from here to here, which they said is 45 meters. 45 meters. The initial velocity is 15. That becomes 15t. For you to get t, you divide both sides by 15. If you want to get t, you get 45 divided by 15 equals 15t. I have to divide that by 15. This cancels this. T becomes 45 divided by 45 divided by 15 becomes 3 seconds. But the question is saying the time of flight. And the time of flight is 2 times small t. So if that is the case, the time of flight is represented by capital T, and that is given by the formula 2 times small t. Recall the expression, the equations I derived. Capital T is 2 times small t. So capital T is 2 times small t now is what we have got as 3 here. 2 times 3, capital T becomes 6 seconds. You have answered the first part of the question. Let us go to the second part of the question. The second part of the question is the height of the wall. If you can recall the equations I derived on that day, you can go to the videos. You can find out that the formula we established for the height when the object is falling. Anytime the object is falling, the formula for the height we said is half gt square or gt square divided by 2. Either you say h equals half gt square or gt square divided by 2. Or you say 1 times gt square is gt square, I have to divide that by 2. So if that is the case, h equals g is 10 times small t, we have got that as 3 here. That becomes 3. Because of the square here, you say 3 square, everything over 2. So h becomes 10 times 3 square is 3 times 3, that is 9, divided by 2. 2 goes here, 1 into here, 5 times. 5 times 9 is 45. That means the height is 45 meters. Drop us